we want to solve this for x. Whenever you want to solve something with an x squared for x, you need to move it and equal to 0. You move everything over and make it equal to 0. Now, if there wasn't an x squared, you'd get x's on one side and numbers on the other. There's a difference. But since there's an x squared, you got to move it all, equal it to 0. So basically, we've got to move this 4x over. When I do that, I now have 2x squared. And then negative 10x minus 4x is minus 14x. And then that cancels, leaving me 0. Okay. Why did I do that? Well, if I factor this side, I can solve it. Now this looks kind of like a weird factoring, but the first thing in all factoring problems is to pull out a GCF. So you should see a 2. You should also see an x in both those. So there's a 2 and x in both of those pieces. So when I pull out the 2x, that leaves me two things left over. 2x times what gives you 2x squared? Hopefully you notice that's x. 2x times x gives you 2x squared. 2x times what gives you negative 14x? Hopefully you notice that's a negative 7. Okay, now how does that help me? Well, doesn't 2x have to equal 0 or x minus 7 has to equal 0? Don't one of those pieces have to equal 0? So either 2x has to equal 0 or x minus 7 has to equal 0. One of those two has to equal 0 to make it equal to 0. So what would make this one 0? Well, if you just divide by 2, so that's 0. So 0 would make it 0. And here we would have minus 7 gives me 0. Oops, I shouldn't have done that way. Add 7 to both sides. X equals 7. So we added 7 to both sides. We got x equals 7. Those are my two answers to solve this original equation. You move everything over, set equal to 0, factor, set both your factors equal to 0. Look at number 6. It's all factored for you. It's ready to go. So what are we basically going to do? Solve it. Now, can you set the 4 equal to 0? What do you get when you set 4 equal to 0? That doesn't really make any sense, does it? So do I really have to set 4 equal to 0? No. You basically are going to set both these pieces equal to 0. Now, here's technically why you don't have to set 4 equal to 0. Could I divide both sides by 4? Is that okay? And the 4 disappears? You could technically have done that. Now the 4 is even gone. You don't have to worry about it even. Or you could just in your brain go, okay, 4 equals 0, can't solve it, done. You could either ignore the 4 when you're solving, or you could divide both sides by 4. Either method works. Okay, now this is basically like this problem. You set each piece equal to 0. Except each piece in this situation, aren't they a little bit more difficult? It's a little bit harder to just stare at that and see your answer. This one you might have to do a little bit more work solving. So we add 3 to both sides. Here we're going to minus 7 from both sides. And then we're going to divide by 2 for this one. Here we're going to divide by 5 for this one. So, we're just going to set each piece equal to 0, solve them each. You get fractions, a little bit more difficult, so most people can't just look at that and see the answer, some people can. But same idea. Now, could I have had an original problem that had a factor to become this? Yes. I just made it easier. I showed you what the end factor looks like, and then set each piece equal to 0. Also remember, if you have a number out front, you can divide both sides to get rid of it. Okay. Now, completely off the factoring topic. We're switching topics altogether. This kind of problem you do not have to solve by factoring, even though you could. You could solve this one by factoring. We're going to use a whole different method to solve this. And here's how it works. Do you understand on both these, 7 and 8, you do not have any just straight x's. It's just x squared. Whenever you just have an x squared and no x's, there's an easier way to solve it than factoring. Basically, you first are going to get the x squared by itself. So you first get the x squared by itself. Now, again, this only works if there's an x squared and no x's. What's the opposite of square? Square root. So watch this. I can undo the square by square rooting. Just like I undo divide by multiply, I undo add by subtracting, I'm going to undo a square by square rooting. And when I square root both sides, you got x equals, now this big square root actually becomes the square root of 25 over the square root of 9. Now I'm going to tell you something right now. There's actually a plus or minus here, and I'll explain that in a second why. Just trust me for now. What's the square root of 25? 5. Okay. So our answer is plus or minus. The square root of 25 is 5. The square root of 9 is 3. So it's plus or minus 5 over 3. Now, do you guys remember almost all x squareds have two answers? That's where the plus or minus comes from. And we'll talk about that a little bit more detail with this problem. It'll make a little bit more sense. Okay, number 8. What we're going to do is we want to get the x squared by itself. To get the x squared by itself, what do we have to do? Add the 8 over. So we now have x squared equals 20. So what's our next step to get rid of the squared? We're going to square root both sides. We now have x equals, don't forget the plus or minus, the square root of 20. That's our answer. But can we simplify square root 20? Back to the beginning of section 5.5, we have to simplify square roots. Square root 20 is what perfect square root goes into there? 5 and 4. Because the square root of 4 is going to be nice and neat. So it looks like we're going to have x equals positive or negative. The square root of 4 is 2, correct? There's our answer. Positive or negative. Now, why is there a plus or minus? Here's where I'm going to get at. What squared, for instance, gives you 9? Let's just think about this. Well, if we square root it, don't we get x equals plus or minus 3? Let's think about it. What's 3 squared? 9. But isn't negative 3 squared also 9? You have to think about that. The answer to this is going to be positive or negative 3. Whenever you square root both sides to solve it, you need to put a plus or minus. Because if you think about something that's more familiar to you, like this, when you square root both, you get 3, but you need a plus or minus again because of the square rooting idea.